Hello viewers, I remain Beatrice Christopher from Statistics Scribe. God's willing, in this tutorials I'm going to show you how to perform one-way analysis of variance, also known as one-way Anova, in Ibm Spss statistics. So for the sake of these tutorials, I have a hypothetical data set, so permit me to split my screen into two, so I'll show you the data set, okay? So quickly, I have my data set here. As you can see, the data is on the scores of students, presumptuously or hypothetically, scores of students with maximum obtainable score of 10. So using teaching method 1, a student scored 7 out of 10, someone 8 out of 10, 6 out of 10. For method B, 6 out of 10, 9 out of 10, 7, 8, and 5 out of 10 respectively, while for method C, 8 out of 10, 5 out of 10, 3, and 9 out of 10 respectively. Now, the whole aim of one-way analysis of variance is to test if there is significant difference in the test scores of these students across each of these teaching method. So what we are trying to say is there significant difference in the academic performance of the students based on the teaching method applied? So here quickly we're going to run the analysis, but before then we have to enter the data. So the ideal way of data entry is to first define your variable. So as you can see here, we have our variables here, which is test scores or scores, and the other one is called teaching method. So quickly I'll come here and we have teaching method A, B, and C. So you come to Ibm Spss statistics, your variable view. Permit me to maximize here, so I'm maximizing, so for easy readability. So quickly here I have a variable called scores, then another variable called teaching method. So kindly check our video for rules for naming variables in Ibm Spss statistics should you not know the rules, okay? So quickly on that scores, my scores, I don't have a decimal, so you can make it 0 if you like. You can leave it. For teaching method, I don't have decimal, leave it. For the numeric here, it's cool because I'm going to assign codes to the teaching method. Then for the scores here, I have test scores of students, okay? Then for teaching method, I can call it method, my bad, of teaching. Then under values here, we don't have a code. Here a level of measurement is scale, and for teaching method, level of measurement is nominal, okay? But under teaching method, we have 3 factors, which is method A, method B, and method C. So quickly under values, we define it. So values here, the first value you can see, let 1 stand for method A. You click on add here or press your enter key on your keyboard. So for the sake of this tutorials and for the first time here, I'm going to click on add. So you can see it has appeared in this box here. Then let's say 2 also stands for method B. Permit me to make mistake here, so I will effect the corrections. That means, so I will show you how to effect it should you find yourself in such a situation. So let's say I mistakenly wrote method K in place of method B. So I'm going to click on add also. So this is an error. To effect the correction, you select the one you want to correct. So I want to correct method K, which is code 2. Click on it, then come to labels. On that label, you effect the correction. It's supposed to be method B, okay? You click on what? Change. You see it has effected it. So the next thing we have is, I'm going to add another one. Effect, clean the whole of this. And type, let's say 3. Method 3. Then the next thing we have is method C, okay? So remember previously I clicked on add, but I want to show you also, I said you can actually use your enter key. So I'm going to use my enter key on my keyboard. You see it has appeared here. Then you click on OK. So you've entered all the 3 methods. This is good when you want to compare the means in terms of data exploration, okay? But if you don't do it this way, your output will still be correct, okay? It's just that sometimes it will not go with the labels, especially if you did not define it or reflect the factor levels, the names, what it stands, else it will just be 1, 2, 3 for advanced analysis. So quickly here, we're going back to our data view, navigate through, you can actually expand this column here, you can expand this for readability's sake. So permit me to minimize now. So I'll split the screen into two. So you'd see the data set once more, and I'll show you how to enter it into IBM SPSS statistics. So quickly, I'm going to enter my data set column wise. Remember, you can actually enter your data set in 3 methods. Now, one of the methods is you enter it column wise. The other is row wise, and the other is at random. Maybe you begin with 9, go to 3, go to 8, depending on what you want to apply. But to play safe, we usually recommend you using either column wise or row wise approach. Okay, so for the sake of these tutorials, I'm going to use column wise approach, right? So it means I'll begin with 7, 8, 6, followed by 6, 9, 7, 8, 5, 8, 5, 3, 9. So quickly, all the test scores will have to be in a single column. Okay, now observe what I'm going to write here. So for scores, I have what the first one is 7, followed by 8, followed by 6. Now if you observe I've entered this, then you go to the next method here, which is 6, 9, 7, 8, 5. So it means here I have 6, 9, 7, 8, 5, and the next we have is here, that's column wise also. We have 8, 5, 3, 9. So it means here I have 8, 5, 3, 9, right? Now the next thing I need to do is to go to my teaching method and classify each test score to its corresponding teaching method. Take for instance, 7 appears in teaching method A, 8 appears in teaching method A, 6 appears in teaching method A. This 6 that appears in teaching method A is different from the 6 in teaching method B, so you have to take cognizance of which method it comes out. That's why we advise you applying row or column wise approach in place of randomness, except if you are sure and you know what you are doing. Okay, so quickly, 7 here appears under teaching method A, and teaching method A is coded 1, while this B is coded what, 2, and C is coded what, 3. Is that right? So for 7, 8 and 6 all appears in teaching method A, which is 1. So it means I'll have 1, 1, 1, right? Then for 6, 9, 7, 8, 5 all appears in teaching method B. So it means I'll have 2, right? Which is the code 2, 2, 2, 2 up to here 5, 2. Then for teaching method C, we have 8, 5, 3, 9, right? So it means I have 3, which is the code for method C. 3, 3, 3, 3. Is that right? So if you observe, all the entries here are corresponding entries in each teaching method. So you can actually toggle around. Because we've coded our data, you can see what each code stands for. But if you did not code it, it will not show. Okay, so to toggle over or around, you click on these value labels. Okay, you click on it, you see method A, method A, method A, method A, method B, method B, method B, method B, method B, method C. Can you see it? So you can easily toggle around. Okay, so quickly let's perform our statistical analysis, which is one-way analysis of variance or one-way Anova. So to do that, all you have to do is you go to analyze. From analyze, then you go to compare means. Compare means, then you go to one-way Anova. So under one-way Anova, the box here, the variable box here, you need to take each of the variables to its corresponding box. If it's a dependent list, place it here. If it's factor, place it here. So our test scores in this case will be in the dependent list, okay, because it's dependent variable. So here we have test scores. Click it, select, then you select our method of teaching, which is our factor. It has 3 factors: factor A, factor B, and factor C. Then you select it and you click on OK. Now in these tutorials, I'm not concentrating on the contrast, post hoc analysis, options, and bootstrap. Okay, all I want you to know is you can actually perform one-way analysis of variance in IBM SPSS statistics. So kindly keep following us. God's willing, we'll show you how to perform all of this, how to utilize all of these buttons here. Okay, so click OK. That's all. Now once you click on OK, observe what we have. This is our one-way analysis of variance output. Okay, so this between groups, within groups, and total. Between groups here stands for treatment, which in this case is teaching methods, and within groups is for error. Okay, now so this means sum of squares of for teaching method, which is 1.500, and sum of squares for error, which is within groups here, is 34.75, and our sum of squares total is this, right? And degrees of freedom for this is this. Correspondingly, this is mean square error for this, mean square error for this, F statistics, and our p-value, which is our significant value to test. Okay, so I hope you like this video. So I'm going to show you how to actually perform the analysis of variance. That means the one-way analysis of variance, which is also called one-way Anova, without actually defining your variables. Okay, but if you observed here, we have test scores of students. If you do not define your variable, you won't have this. And should you want to run some advanced analysis, it will be difficult or complicated for you to know which code stands for which factor. Okay, so straightforward, I'm going to show you how to. So looking at the data set here, now we are assuming we are not defining our variable, we just want to perform the analysis directly. Okay, so all you have to do here is just come to IBM Spss statistics here, type the values. So permit me to use row wise this time around, so you know we can actually use different methods. Okay, you still get the same answer. So I'm taking it row wise in this case, 7, 6, 8. Okay, so I have 7, 6, 8. Right, then the next thing is we have 8, 9, 5, 8, 9, 5. The next one we have is 6, 7, 3, 6, 7, 3. The next one we have is 8, 9, 8, 9, and the last but one is 5. Okay, then now we want to code it here. As you observe, the default variable name is var00001. That's 4 zeros with 1, right? Then the next one, permit me to expand it. Here we're going to have our factors. Now 7 appears under method A, which is 1 for coding. 6 appears under method B. 8 appears under method C. So it means we have 1, 2, 3. So here I'm going to have method 1, method 2, method 3. Then 8 appears under method 1, which is A. 9 under B, 5 under C, meaning we have 1, 2, 3. Also 1, 2, 3. Then the next one we have is 6 under A, 7 under B, 3 under C, which is 1, 2, 3. So I have 1, 2, 3. Then the next one we have is 8 under B, which is 2, and 9 under C, which is 3. It means in this case we have 2, 3. Take note of the fact that there's no A here, so no 1. So it's going to be 2 and 3. For 8 and 9, it's going to be 2 and 3, right? Then the next one we have is 5, which is under method B, which is 2. Then you select 2. Okay, press enter. That's all for that. You can perform the analysis without any change in any variable or defining the variable, but it would be ideal to do that. So let me expand it in here. I'm maximizing it. So you come to analyze, come to compare means, then one-way Anova. So under one-way Anova, observe var00001 is our dependent. You see how confusing it can be sometimes, right? That's why we advise you to define your variable in IBM SPSS statistics. So dependent list is var0001 because it's our dependent list, and our factor is here, which is var0002. You take it to the factor here, then you click on OK. Observe the output here. Observe this and this, they are all the same, right? So kindly like, share, subscribe, hit on the notification bell for more updates. Okay, trust me, we have lots of things for you.